Yeah. So when is sequence said to be Cauchy sequence? Sequence is denoted either by UN or by SN, any notation, okay, or this notation, any notation. So this is said to be Cauchy sequence if given epsilon greater than 0, there exist p comma q positive integers such that sp minus sq is less than epsilon for all p comma q for all n greater than or equal to n. For all n greater than or equal to p comma q. So earlier we stated for all n greater than or equal to m. Now for all n greater than or equal to p comma q. What is the meaning is, what is the difference between sequence and Cauchy sequence? Sequence means Sn minus n less than epsilon for all n greater than or equal to m. M is a positive integer, in some textbooks real number. We have done questions based on that. Now instead of m, two positive integers. That means what is the meaning? Earlier we discussed n greater than or equal to m means n equal to m, m plus 1, m plus 2 onwards. This difference Sn minus L less than epsilon. Epsilon itself is, what is epsilon? Smallest positive real number. This is something less than epsilon. Epsilon itself is small. So obviously Sn minus L will be very small. Very small means approaching 0. Very, very small. That means difference is negligible. Difference negligible means what? Sn is almost equal to L. So that is from M onwards. What is the sequence here? Sn means, we discussed elaborately earlier, S1, S2, S3, Sm, Sm plus 1, and so on. So sometimes from the beginning itself it may be close to L. Sometimes first few terms may not coincide. But from M onwards, it appears as if it is approaching a number L, real number L. That L towards which it is proceeding, converging, is called limit of the sequence. So that's how we have seen. Sometimes, as we have discussed many times, 1 by 2, sometimes this is 1 by 4, 1 by 6, or 1 by 8, and so on. This is nothing but the sequence from the beginning. It is moving. What is the nth term? S1, 1 by 2, S2, 1 by 2 into 2, 4, S3, 1 by 2 into 3, 6. Sn will be 1 by 2n. This is a sequence. From the beginning, it is following systematically some pattern. N equal to 1 to infinity. N equal to 1 will give you first term, n equal to 2 will give you second term, 3 will give you third term. From the beginning itself, it is following some like systematic pattern. And what is the limit of the sequence is? Limit of the sequence is defined as limit of the nth term of the sequence. So limit of 1 by 2n, which goes to, as n tends to infinity, this will go to 0. 1 by infinity is 0. So we say this is our L. This sequence converges to L, which is 0. This is one time. From the beginning itself, S1 itself, it is following some systematic pattern. Sometimes what happens is, we cannot predict 1, 0, then suddenly it will jump to 1 by 2, then suddenly it will jump to 1 by 3, then 2, 1 by 6, 1 by 9, 1 by 15, 1 by 12, and so on. What we observe is this is S1, S2, S3. So M equal to 1, S1, S2, S3. Up to this, we could not predict what is the nth term. But from 4 onwards, S4 onwards, we are able to see there is a systematic pattern here followed. From 1 by 3 onwards, 1 by 3, 1 by 6, which term onwards? 1, n equal to 1, n equal to 2, n equal to 3, n equal to 4 onwards. It is following some pattern, suffix when you take. It is following some pattern. This value from which it is following some systematic pattern, that is called M. What is M? N equal to M, which is 4. Next is M plus 1, M plus 2. That is from 4 onwards, fourth term onwards. It is following some pattern. So from the beginning, it is not systematic, zigzag. So from which term onwards it is following systematic pattern, that is called our M value. That is for n greater than or equal to M, which is 4. It is following some pattern. Then what is the nth term? From here we observe that the nth term is 1 by 3, 1 by 3 into 2, 1 by 3 into 3, 1 by 3 into 4. This is 1 by 3 into n. Most of the terms, first 3 are not matching, but fourth term onwards, it is approaching to a fixed number. So limit of the nth term, we take nth term as this, which is 0. This is our n. So limit of the sequence, the given sequence Sn, we say it is nothing but 0. Because majority of the terms, after certain term, it is approaching. From the beginning, we know. Whereas here, m is 1, your n equal to m equal to 1. From first term itself, it is following some systematic pattern. But whereas here m is 1, here m takes many values, the least value is 1. So here m value is 4, we take from 4 onwards, it is following. This is what is called limit of the sequence. As I told you in the beginning, some students, they will have a strong determination from the beginning itself. If you ask a child, they know what they want to become. Maybe previous birth impressions. They know from the beginning. You can see babies singing from the childhood. They want to become musicians. Some hereditary things. So they want to become something from the beginning itself. There is a determination what they want to become. So that is like this. Their goal is becoming something. That goal they will definitely reach because they are going to they are progressing from the beginning. Some want to become IAS officer, some want to become doctor, some want to become engineer. From the beginning itself, they have those tendencies. But whereas sometimes what happens in the beginning, they might not be having anything, no targets. Afterwards, because of teacher or your interest created by somebody, you enter into a field. So that becomes your life goal. You want to become something. So you are, for example, you entered into mathematics. I don't know at which stage. So then you entered into MPC. After intermediate 10th class, you did okay. You want to go for MPC. Then you have determined something you want to do, MSc mathematics, because you have set your goal to become settled down in mathematics field. Now you have reached the goal. You have reached the goal called settling into mathematics. That is the reason why you are in this group. So you're moving towards settlement in the mathematics field. That is the limit. L is now your goal is to settle down in mathematics field. Either teaching or non-teaching, where you will go, we don't know. Want to do some PhD in mathematics. So you want to be in mathematics. That is the reason why you are this. So you have reached your goal of settling down in mathematics. So you have completed your MSc Maths, or you want to attempt and enter into IITs and central universities for doing your MSc Mathematics course. So this is the limit. So you might not be having from the beginning the goal, but in between it started somewhere in your career. This has become now the career destination. That is your real. So this is how the sequences will be. Sometimes from the beginning itself, sometimes from the beginning zigzag. One day you will say you will become scientist, another day you will say you will become engineer, another day doctor. You don't know what you will become. You don't have any proper determination. Then slowly you will enter into this. So this is the goal of your this ultimate settlement career wise. So this is what is called limit of this is limit of the nth term. That is majority after some time will approach this one. This is sequence. Now we are having now Cauchy sequence means SP minus SQ less than epsilon for all n greater than or equal to p comma. Means in some textbooks they take SP minus Sn plus p minus SP or SP minus Sn plus p. Anything okay because modulus is there. S m plus p less than epsilon or n plus p for all n greater than or equal to p. Some textbooks they take instead of q n plus p. So q can be anything. So less than epsilon. That means we want to any two members you take in the sequence. In the sequence, your SP is one member, your SQ is one member somewhere. So and so on. There is no end for this. So here if you take m, n greater than or equal to m greater than or equal to p, like that you can have. This is Sn or Sm, whatever is the notation. Q is your some terms in terms of p. Then any two members, SP and SQ means any two. You take S1, S3 or S2, S100. Any two members you take, if the difference is very small, that means the members are close to each other. Then we say such a sequence is Cauchy sequence. That means difference between every two members is negligible. Then it is called Cauchy sequence. Then how do we test whether the sequence is Cauchy sequence or not? Very happily I am saying it is Cauchy sequence like this. Definition is this. But given a question, how to identify whether the sequence is Cauchy sequence or not? So for this we have a principle called Cauchy's convergence principle. So how to test whether sequence is Cauchy or not is a sequence is Cauchy sequence if and only if sequence Sn is Cauchy sequence if and only if it is convergent, or it is the other way. Sequence is convergent if and only if it is Cauchy sequence, or sequence is Cauchy sequence if and only if the sequence is convergent. Both the sides. You can write vice versa. Because if and only if statements means P double, that is P implies Q, Q implies P, both are true. So you can say vice versa. So when is sequence said to be Cauchy sequence, therefore, see, in your SEM exam, don't apply these methods. These are only in the entrance point of view we are doing. So you do according to your teacher methodology. But when do we say it is Cauchy sequences? Your teacher might have taken some questions of Cauchy sequence and proved some 1 page or 1.5 page in some other methodology. But here in the entrance point of view, how we test is, if it is convergent, then automatically it is a Cauchy sequence. If it is Cauchy sequence, automatically it is convergent. So a sequence is Cauchy if and only if it is convergent. So suppose you are given questions now. So how will you test? To check Cauchy sequence or not, test whether it is convergent or not. So when is sequence said to be convergent? Sequence is said to be convergent provided limit of the sequence is finite and unique. If it is finite and unique, then we say it is convergent. If it is infinity, we say, or minus infinity, we say it is divergent. We have done questions earlier, many questions. If L is finite but not unique, then we said the sequence is oscillatory, not convergent. Oscillatory means not convergent. Divergent also means not convergent. This also means not convergent. Not convergent means it may be divergent or it may be oscillator. Both will come under not convergent. And one more we have seen, if the limit L is infinity sometimes, minus infinity sometimes, infinity and minus infinity. For some values of n, it is infinity. For some values of n, it is minus infinity. Then we say it oscillates infinitely. We say the sequence Sn oscillates infinitely. This is what we studied. We have seen number of examples. So in any case, in these three cases, it is not convergent. In this case also not convergent, not convergent, not convergent. If it is not convergent, it cannot be Cauchy sequence. Remember, if it is convergent only, it is Cauchy. Not convergent, not Cauchy. Because if and only if statement. So in order to test any sequence is Cauchy sequence or not, best principle is test whether it is convergent or not. To test convergence, we use this. So for example, question may be given, which of the following are Cauchy? They are given question, Cauchy sequence. First one, let us say 1, 1 by 2, 1 by 3, 1 by 2, 1 by 4, 1 by 6, 1 by 8, 6 already we have seen, 8 and so. I will have here 1 by 3, 1 by 6, 1 by 9 and so. 1 by 1 square, 1 by 4, 1 by 9. And so. For example, I want to know whether these sequences are Cauchy sequences or not. How are we going to test? So to test whether they are Cauchy sequences or not, another one is n plus 1 by n ranging from 1 to infinity everywhere. Minus 1 power n by n. 8 plus 1 by n square. So let us test whether they are Cauchy sequences are. If it is as I said, some exam don't do like this. If you fail in your exam, I am not responsible. Institute is not responsible for your failure. Okay, this is only in the entrance point of view we are doing. Some exam, different methodologies are there because that is descriptive. So I have to answer accordingly. Okay, now first one, how to test whether it is convergent, how to test whether it is Cauchy or not. We are going to use the principle that is convergent. Cauchy convergent principle. That is, sequence is Cauchy sequence, then automatically convergent. If it is convergent, it is Cauchy. If and only if statement. So I'm testing. First one. 1, 1 by 2, 1 by 3, and so on. For this, 1, 1 by 2, 1 by 3, and so on. What is the nth term of this series? This can be rewritten in the form. All of you know. This is nothing but the sequence Sn, let us call it, let us give a name. This is nothing but 1 by n ranging from 1 to infinity. So testing whether the difference is small or not, that is difficult. Theoretically, okay. Sp minus Sq should be very small, but practically difficult. So we go for this. So this is Sn. So is this sequence convergent or not? What is limit of this sequence? Limit of the nth term, Sn. Sn is n. Nth term. Now this is 0, which is finite and unique. If it is finite and unique, automatically it is convergent. Therefore, sequence Sn converges. If it is convergent, automatically it is Cauchy. which implies sequence converges to 0, is convergent sequence. Converge, which implies sequence Sn is Cauchy. This is how easily we can test. So how to test whether it is convergent or not? We have done number of questions using Cauchy's first principle, second Cauchy's first theorem, second theorem. You may get nth term, any one of them. So apply any one of the techniques which you have learned earlier, then apply that and see whether it is convergent. So then, if it is convergent, automatically it is Cauchy. So this sequence is Cauchy sequence. So like this, we try to test. Second one is 1 by 2, 1 by 4, 1 by 8, not 6. If it is 1 by 6, it is something. So the sequence is 1 by 2, 1 by 4, 1 by 8, and so on. What is the nth term? Any one of you, can you predict?
1 by 2n, sir. Madam.
1 by
2 power n.
2 power
1
n.
by 2 power n.
2 power n. It is not 2n because n equal to 1 will give you 2, n equal to 2, 2 square, n equal to 3, 2 cube, 8, not 6. If it is 6, 2 into n. If it is 8, 2 power n. Now this is our nth term. So what is Sn equal to? 1 by 2 power n. So what is the limit of the sequence? So limit of Sn is nothing but equal to limit Sn 1 by 2 power n. All of you know what is this limit? What is the limit of this? 0. Why is it so? Because limit r power n is 0. If mod r is less than, it is applicable even for negative. So modulus of r, this is in the form r equal to 1 by 2 here, 1 by 2 power n. So which is less than 1. Mod r, mod 1 by 2, less than. Therefore it is convergent. Limit Sn is 0. Therefore sequence Sn 1 by 2, 1 by 4, 1 by 8 is convergent sequence. Hence Cauchy. If it is convergent, automatically it is Cauchy. Convergent sequence, hence Cauchy. Hence Cauchy sequence. Next one, 1 by 3, 1 by 6, 1 by 9. What is the nth term? Easiest
1
question.
by 3n.
1 by 3n. 1 by 3n. 1 by
1
3
by
power
3n,
n,
sir.
1 by 3n, 1 by what is this? Equal. What is the nth term? It is not 3 power n, 3n. Because if you put n equal to 1, 3, 3 ones are 3, 3 twos are 6, second term, 3 threes are 9. 3 power n means 1 by 3, 1 by 9, 1 by 27, like that you will get. So this is our Sn now, 1 by 3n. So easily you can find the limit. So what is limit of the sequence is limit of the nth term. So this is limit 1 by 3 Sn, which is limit of 1 by 3n. As n tends to infinity, 1 by 3n will go to 0, which is finite and unique. It need not be 0 all the time. Finite and unique sufficient. Therefore, the sequence Sn is convergent sequence. If it is convergent, automatically it is Cauchy. Is convergent sequence. Hence, Cauchy sequence. Not convergent, not Cauchy, because it is if and only if statement. Next one is 1 by 4, 1 by 9, and so on. So all of you must be knowing this. What is the nth
1 by
term
n
for
square, sir.
1 by n square.
N square.
N square, correct. 1 by 4, 1 by 9. So this is 1 by n square. Nth term is 1 by n square. N equal to 1. So Sn is 1 by n square. So what is limit Sn? It is nothing but limit of Sn, nth term, which is 0, which is finite and unique. Finite and unique. Therefore, sequence Sn is convergent. Hence, Cauchy is convergent sequence. Hence Cauchy. Hence Cauchy sequence. Next one more. So
Next
always
one
we have,
convert to ones, madam.
next one is n plus 1 by n. Nth term is given to you, n plus 1 by n. So let us see. N plus 1 by n. E bit. 1 plus n plus 1 by n. N equal to 1 to infinity. This is Sn. So Sn is equal to, you need not find the nth term, it is given to you. So we have to find limit of the sequence, means limit of the nth term. So limit of n plus 1 by n. All of you know the answer for this. What is the limit of this? As n tends to infinity, we have to take separate LCM. N by n is 1 plus 1 by n. As n tends to infinity, this is 1, which is first time we are getting non-zero term. It is finite and unique. Need not be zero. Some students, because most of the time we get zero, students get an impression if it is zero only convergent. No, it is finite and unique. It can be anything. It's finite and unique. Then it is convergent. Hence convergent. 1 by n is convergent. Hence Cauchy sequence. Hence Cauchy. So sometimes nth term will be given to you. Sometimes directly you will be given sequence. You have to get the nth term like that. Next one is Sn equal to minus 1 power n by n. By looking at this minus 1 power n, students they conclude it is not convergent. So it is not so. So what is this sequence? Sn, we have to find the n limit. Limit of the sequence is, what is the sequence actually? If you are interested, you can expand. This will be minus 1 plus 1 by 2 minus 1 by 3 plus 1 by 4 and so on. You can see n equal to 1. Minus 1 power 1 is minus 1 by 1. N equal to 2. Minus 1 square is 1 by 2. N is 3. Minus 1 cube is minus 1 by 3 and so on. Limit of the nth term, that is minus 1 power n by n. So as n minus 1, this is nth term. We cannot directly find. I told you earlier. Whenever it is like this, minus 1 power n, minus 1 power 2n, something n square, we have done many questions. We have to find the nth term. Don't do it directly. Because if you do it directly, some students will get out minus 1 power infinity. What is that? So, whenever you are getting minus 1 power n, we have to divide into two cases. N is even, n is odd. In each case, if it is convergent, then only we say overall it is convergent. So, whenever you get minus 1 power n, don't do it directly. First simplify, then apply. Before applying limit, first you have to simplify. How to simplify this? If you put n equal to 1, n is even. If n is even, minus 1 to the power of even number is 1. So 1 by n, if n is even. And minus 1 power odd number will be minus 1. So Sn will be equal to minus 1 by n if n is odd. So we are getting two n terms. If n is even one n term, n is odd another. In each case, it should be convergent. If it fails in any one of the cases, it is not convergent. Hence not Cauchy. So, but let us do it. So first case will do. So case 1, if n is even, this will be equal to limit 1 by n, which is 0, 1 by infinity, if n is even. So if n is even, limit is 0. Limit of the sequence is 0 if n is even and is finite, unique, hence convergent. Let us see n is odd. This will be limit n tending to infinity minus 1 by n if n is odd. Minus 1 by infinity is minus 0, which is 0 if n is odd. So in both the cases, we are getting same limit and finite and unique. Both the cases, when n is even also finite and unique, n odd also finite unique. Sometimes what happens, here 0, here you will get 1. Here also unique, here also unique. Individually, in this case convergent, in this case convergent. But here 0, here 1. Limit is not unique. Here we are getting sometimes 0, sometimes 1. That means two limits we are getting. So limit is not unique. Finite, not unique. Hence we say it oscillates finitely if you get different limits here. So then it is not convergent, hence not Cauchy if you get anything other than this. But in both the cases, it is convergent. Not only that, in both the cases, same limit. Therefore, we say that here the sequence Sn converges for all n. Therefore, Cauchy minus 1 power n by n is Cauchy. Cauchy sequence. Some students, why they get the doubt? Minus 1 power n means oscillatory is. I'll take up another question, extra question. This is. It is not there in the list which I have given. Minus 1 power n. Suppose you want to know whether it is Cauchy sequence or not. So how to know whether it is Cauchy sequence or not? Because minus 1 power n is there, we have to divide into two cases, n even, n odd. Minus 1 power n. This is 1 if n is even and is minus 1 if n is odd. So what is the limit of the sequence therefore? Limit of the sequence is limit of the range. So limit of Sn will be equal to 1 if n is even. Because as n tends to infinity, 1 is 1 only. And will be equal to minus 1 if n is odd. So limit is finite, but not unique. So sometimes limit of the sequence is 1, sometimes minus 1. Individually, they are convergent in each case, but both the limits are not same. Therefore, we say that the sequence Sn is oscillatory because we are getting minus 1, sometimes 1 or minus. Sometimes 1, sometimes minus 1. Therefore, limit is finite but not unique. Therefore, we say sequence Sn is oscillatory. It oscillates finitely, hence not converge. Oscillate, hence not converge. Therefore, if it is not convergent, it cannot be Cauchy sequence. Therefore, sequence Sn, which is 1 minus 1 power n, which is 1 minus 1 minus 1 1 minus 1 1 and so on, is not Cauchy sequence. So if it is not convergent, it is not Cauchy. And what is the other one? So don't think, for example, minus 1 power n by n is there, it is Cauchy. Only minus 1 power n, it is not Cauchy. Okay. Next, completed. Last one. 8 plus 1 by n square. The sequence. 8 plus 1 by n square.
8, sir.
So G is
Cauchy sequence.
8. Correct. 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 It is convergent. Cauchy sequence. It is Cauchy. 1 to infinity. Then Sn is actually, what is the sequence when you look at it? 8 plus 1 by n 1 square, 8 plus 1 by 2 square. It is like this. 1 by 1 square, 1 by 2 square, 8 is fixed. So what is limit of the n sequence? Limit of the nth term. Only when you get minus 1 power n square, then only go for even and odd concept. So limit 8 plus 1 by n square. As n tends to infinity, this is 1 by infinity 0, 8, finite and unique. Hence converge. Therefore, sequence Sn is converged. Hence Cauchy. So without putting pen on the paper, you can answer. Hence Cauchy. So like this, sometimes you may be given a question like 1 plus 1 by 3, 1 by 5, 2n minus 1 divided by 2. This is the sequence. Is this Cauchy sequence? Any one of you, can you answer?
Cauchy sequence, sir.
Cauchy sequence? Cauchy, why Cauchy sequence?
Using
So-
first theorem on limit.
Correct, good, Sarita. So using Cauchy's first theorem.
Yeah, sir.
Cauchy's first theorem. This is in which form? That you have to identify. So, what is the sequence Sn? Nth term of the sequence is in the form Cauchy's first theorem. First theorem. Cauchy's first theorem on limits. So, applying that you get. So, very good. You are able to identify. So, what is Sn equal to? Those who are attending for first time
1
today,
by
this is like this. Whenever a sequence is in this particular form, n terms, arithmetic mean like n arithmetic means sum of the terms by this, then such a sequence is Cauchy's first theorem. According to Cauchy's first theorem, S1 plus S2 plus and so on up to Sn by n limit is limit of Sn. This is what is Cauchy's first theorem on limits is. So whenever you have a limit of this is equal to limit of this, that is limit of any term, any sequence whose nth term is in this particular form is limit of the nth term. So instead of Sn, we are having 1 by 2n minus 1. So what is the limit of this sequence is limit of the nth term, Sn. But in this, what is the nth term is 1 by 2n minus 1. So limit 1 by 2n by Cauchy's first theorem on limits. As n tends to infinity, 1 by 2 into infinity is infinity, infinity minus 1 infinity, which is finite and unique. Therefore, the sequence given by this nth term, whose nth term is this, is Cauchy's. It is convergent, hence Cauchy's. Like this, you can apply. We have done number of questions for convergence, hence Cauchy. The questions which you have not, you might not have seen anywhere, that some 80 questions we have done. Sometimes it is bounded function into this. Sometimes you may be given the sequence, for example, because anyway we have come up to this 1 by, for example, 1 by n sine n square. You are given some, suppose, is this Cauchy sequence? Yes or no?
Yes, ma'am.
Yes. Why yes? What is the limit of this
Sin
sequence?
means 0.
Sn is 1 by n sine n square. In turn, it is containing two sequences. So this is one sequence, this is another sequence. This is looking like un tn. So we have done one we are having one result. Whenever there are two sequences, if one of them is bounded, the other one limit is 0, then overall limit is 0. So you can see un is 1 by n, limit un is 0, as n tends to infinity, 1 by n is 0. So un limit is 0, limit un is 0, and Tn is a bounded function. You know, sine theta, whatever may be theta, instead of theta, you're having in n square. So modulus of sine theta is always less than or equal to 1 for all theta. Whatever sine and cos are always bounded functions. Tan we cannot say, because tan is having least value minus infinity, greatest value infinity. But sine, least is -1, highest is 1. Cos also. They are bounded functions for all theta. Instead of theta, we are having n square, it is bounded. So whenever you are having two sequences, if one of them is bounded, the limit of the other one is 0, then limit of product is 0. Therefore, here we are having limit Tn is bounded sequence. Tn is bounded. Therefore, un is limit un is 0. Therefore, sequence Sn, limit of this sequence is limit of 1 by n and sine n square, which is 0. Because one of them limit 0, the other is bounded. 0 into bounded function, limit is 0, which is finite and unique. Like this, we have done many questions. Very interesting questions. Finite, not only finite, and unique. Therefore, the sequence Sn given by this is convergent and Cauchy. Okay. So please go through the previous videos. So whenever you get any question, work out any one of the methods which we have followed for finding limit. Then check whether it is convergent. If it is convergent, Cauchy. Not convergent, not Cauchy. For example, one more question. This is the last one. What can you say about this? Is it is this Cauchy sequence?
Yeah, respond.
No, madam.
No.
No.
Not a Cauchy sequence. Oh no.
Why it is
No.
not Cauchy sequence? Because what is the
Square,
limit?
sir.
Divergent.
N square. So what is
square.
the sequence Sn is? N square.
Infinity.
1 square, 2 square, 3 square, n square. So what is the limit? Limit of the sequence is
Infinity.
limit n square, which is infinity. Infinity square is infinity. If it is not infinity or minus infinity, it is divergent. Divergent means not convergent. Not convergent means not Cauchy.
Not Cauchy.
Not Cauchy. It's not convergent. Divergent actually. So divergent means you can say not convergent. Hence, sequence Sn is not Cauchy sequence. So we have done positively as well as negatively. We have seen oscillates finitely and divergent, convergent. This is not Cauchy. We'll do one more and then we'll close this topic. Is next question. Is the sequence -1 power n into n cube
Respond all. Under respond కావాలండి.
convergent? Cauchy
Divergent, sir.
1 minute.
Is it divergent Cauchy sequence? Reason.
Divergent, sir. Divergent.
Divergent.
Minus
Divergent.
infinity and infinity, sir.
Divergence.
So
Minus
is it
infinity.
convergent Cauchy sequence? Second thing.
Oscillates
Okay.
infinity, sir.
No. It is not Cauchy. I'll give you reasons. It is not Cauchy. You are only saying it is not Cauchy because I will give you reasons. I'll give the reasonings. Majority of them are saying something. Therefore, because sequence is divergent. Let us see the reasonings. Sequence Sn is oscillates finitely. Sequence Sn oscillates infinitely. Oscillates infinitely. What is the reason? It is not Cauchy, everybody is saying. Correct. But what is the reasoning behind it?
Oscillates
All
infinite.
the 3 are
Oscillates infinite,
all
sir.
the
Somebody is saying a divergent
Oscillates
earlier.
infinite.
Earlier they said it is divergent. Now you are saying oscillates infinitely. Why is it so? Is very important. We have seen oscillates finitely earlier. Now this is oscillating infinitely. As I said, whenever you are given minus 1 power n, you have to divide into two cases. N is even, n is odd. Okay. So if n is even, what happens? Minus 1 power n is 1 n cube. If n is even, then this will be equal to n cube again minus n cube if n is odd.
Odd.
So in this case, you will get infinity cube infinity, here minus infinity. So you are getting limit infinity sometimes, infinity plus infinity sometimes, minus infinity sometimes. That means you are getting two limits and both are not unique, and both are not finite also. If they are finite, not unique, then oscillates finitely. But here oscillates infinitely. This is what is called oscillation. Oscillates infinitely. Therefore, not convergent. Whether it oscillates finitely or infinitely, not convergent. For us, what is important is it convergent or not convergent? Hence, the sequence is not Cauchy. Suppose I'm not able to leave. Sarita made me to enter into this. Is the sequence Cauchy sequence? N square shall we take? N. One more, I'll take n square. Same, n square. So,
Is Cauchy sequence, sir.
which one is Cauchy sequence? First one or second one?
First one.
First one is Cauchy sequence.
not
You are saying
not Cauchy, not
not Cauchy.
Cauchy.
first
Second one,
Cauchy.
Not
second one, Cauchy, not Cauchy.
Cauchy sequence.
Cauchy
Cauchy.
sequence, sir.
Second one, huh?
Second.
Convergent.
Second
Hence-
one.
First
Yes,
and
sir.
second one
Yes,
also.
Second one also Cauchy.
Yeah.
Third one, let us analyze. Your friends are saying
Third
something.
one Cauchy sequence.
Third one? Okay.
Cauchy.
Correct.
But this
third one Cauchy
sequence, sir.
Third one is definitely Cauchy sequence.
Definitely.
Yes, sir.
Second one and first one, let us analyze. Some are saying Cauchy, some are saying not Cauchy. Let us see. This question, Sn is 2 power 1 by n. Okay. Third one I am doing. Limit of the sequence is limit n tending to infinity 2 power 1 by n. As n tends to infinity, 1 by n goes to 0. 2 power 0 is 1, which is finite and unique. Hence, convergent. Hence, Cauchy. Therefore, the sequence 2 power 1 by n in the exam, you may not be given directly like this. You may be given 2 root 2 be given, because you can see n equal to 1, 1 by 1, 2 power 1. N equal to 2, 2 power 1 by 2. 2 power 1 by 2 is root 2. N equal to 3, 2 power 1 by 3 means cube root of 2. Like this, it may be given sometimes. Then you have to predict the nth term. Luckily or unluckily, you are given this. But if the question is given like this, you have to write 2, 2 power 1 by 2, 2 power 1 by 3. Therefore, nth term is 2 power 1 by n. Therefore, this limit is finite and unique and is convergent. Hence, Cauchy. Okay. Next, let us go to second question. Minus 1 power n square now. So, question 2. Sn is 2 power minus 1 power n square. Whether n or n square, you have to divide into 2 cases.
2 pieces.
2 power minus 1 power n square. We have to divide into 2 cases. N is even, n is odd. So, if n is even, what happens? N is even.
1 by 2.
N square
It's
is
2.
even. N square is also even. Okay. And minus 1 to the power of even. Minus 1 power even number is 1. Do you agree? N is even,
Yes, sir.
n square is even.
Yes.
Yes,
So
Yes,
what
ma'am.
will be your Sn? Sn will be 2 to the power of 1, which is 2 if n is even. M. Next one. Second case, n is odd. If n is odd, what can you say about n square? 1
Even.
square, 3 square, even అవుతుందా? ఇక్కడే
Odd.
Odd అవుతుంది మేడం. Odd అవుతుంది.
n plus n is even. Odd plus odd is even. Odd into odd is odd. Odd. This is where students they go wrong. So therefore minus 1 power n square becomes minus 1. Minus 1 to the power of odd number is minus 1. So what will be your Sn therefore? 2 to the power
1 by
of n is odd. Therefore now, what are the two values we got for Sn? It is 2.
2 minus 2.
N is even.
1 by
1 by 2. 2
2,
power
1 by
minus 1 means
1 by
1 by 2 if n
1
is
by
odd. Now tell me whether it is Cauchy or not. Everybody is saying Cauchy, Cauchy.
No, ma'am.
Thinking minus 1 power n square is the same you thought, and some majority of you are saying it is Cauchy. But you can see limit of the sequence is, it is nothing but 2. Limit of 2. N tending to infinity 2, which is 2. If n is even. And is equal to limit 1 by 2. 1 by 2. If n is
odd.
therefore limit of the sequence is finite but not unique. So it oscillates finitely. Therefore sequence Sn oscillates finitely. So is it convergent? No,
No, ma'am.
not convergent. Therefore sequence Sn is not Cauchy. Therefore, the sequence minus 1 power n square is not Cauchy. This is how we have to work out questions. We have done some 80 questions like this for convergence, if I remember. Go through the previous cases and 2 power last question, 2 power minus 1 power n. So 2 power minus 1 power. Because of that n square, you got tempted actually. Some students thought you will get same answer because minus 1 to the power of something you got. So you entered into that mesmerization of n square and you concluded like that. So you should be very, very careful. Don't be overconfident. So Sn. What is minus 1 power n? N even and odd. So it is equal to 1 if n is even. Same answer you will get. And is minus 1. Same as previous case.
Yes.
Same as previous case. So limit Sn is, what will be Sn therefore? 2 power 1 if n is even. 2 power minus 1 if n is odd. Same answer we are getting, same conclusion we get, but question is different. Wantedly I have chosen same question, same 2. So what is limit of the sequence? It is limit of 2, which is 2 if n is even and is equal to 2 power minus 1, 1 by 2 if n is odd. Limit is finite and unique, not unique. So this implies sequence Sn oscillates finite. Because 2, 1 by 2, not same. Not hence not converge. Therefore, see, not convergent does not mean divergent. It may oscillate finitely, it may oscillate infinitely. Not convergent means 3 cases. Divergent also not convergent. Oscillates finitely also not convergent. Oscillates infinitely also not convergent. So all the cases we have seen. So which implies the sequence Sn, which is 2 to the power of minus 1 power n, not Cauchy sequence. Sometimes you may get theoretical questions. If Sn is Cauchy, is it bounded? Every Cauchy sequence, can we say it is bounded? Every bounded sequence, can you say it is Cauchy? Like this. So let us see that. So next question is every Cauchy sequence convergent? Every Cauchy sequence convergent. So if it is Cauchy, can you say it is convergent? Yes. Yes.
Yes, ma'am.
No. Need not be. Three you will get. What is your answer? Is every Cauchy sequence, bounded? Every Cauchy sequence, I'm sorry. Is every Cauchy sequence bounded?
Yes, ma'am.
Answer is yes. Why is it so?
Every Cauchy sequence is convergent. So convergent sequence is bounded.
Correct, excellent. Correct, good. Because answer is yes, because every Cauchy sequence is convergent.
Convergent.
Every convergent sequence is
Bounded, madam.
bounded. Every Cauchy sequence is
Bounded.
convergent. Convergent. And every convergent sequence we know bounded. So transitive property. Every convergent sequence is bounded. Hence, every Cauchy sequence is bounded. So remember this as statement. If Sn is Cauchy sequence, which of the following are true? You may get questions. the sequence is convergent, sequence is not convergent but bounded, bounded and convergent. Like this, options will be given. Every Cauchy sequence is bounded. Every Cauchy sequence is convergent. Every Cauchy sequence is bounded. Sometimes you will get a question like this. Every bounded sequence. Is every bounded sequence Cauchy?
Need not be.
Respond. Respond all.
Is every bounded sequence a Cauchy sequence?
Need
Bounded
not be.
sequence need not be convergent.
Correct. So, correct. Good. So, need not be. Need not be means there are bounded sequences which are Cauchy. There are bounded sequences which are not Cauchy. So, we cannot say universally yes. We cannot say universally no. There are examples where they are bounded and Cauchy. There are examples where they are bounded but not Cauchy. What is the example? So example is bounded sequence. What is meant by bounded? There exist two constants like this. Then K1 is called lower bound, K2 is called upper bound. If upper bound and lower bound exist, then such a sequence is said to be bounded sequence. So if the nth term of the sequence or the range of the sequence is bounded, we say sequence is bounded. So this is if it is satisfied for all n or mod Sn less than or equal to K for all n. In both the cases, we say sequence is bounded. The sequence Sn is bounded provided this is satisfied. So what is the example is? Any one of you, are you ready with the example? Bounded sequence not Cauchy?
Minus
Sin n pi by
Minus
2.
one
Minus
whole
one,
power
no.
n.
Correct,
Minus
perfect.
1 to the power n.
Perfect. So this is minus 1 plus 1 minus 1 plus 1. All the members here. What is the nth term? It is minus 1 if n is odd, plus 1 if n is even. So what is the range of the sequence? What are the different values it is taking? The
One
range of the sequence is minus 1 and 1. Range means different values the sequence is taking. So this is a set action. Range is nothing but a set. So for this set, you know what is lower bound, what is upper bound. So all the members of the sequences, they are between minus 1 and plus 1. All of them. Actually, they are equal, either equal or less. So therefore, it is bounded, but it is not convergent. Is bounded, but not convergent. As it oscillates. Finite. Hence, not Cauchy.
Not Cauchy.
So next one, example where
One
it
by
is bounded and convergent.
1 by
Example.
n.
Minus
Correct,
1
good,
to the power n
excellent,
by 1.
excellent, excellent. 1 by n.
1 by n.
That is 1, 1 by 2, 1 by 3, 1 by 4. What is the range of the sequences? Total. All are distinct only. What are the bounds for this? Sn is 1 by n.
0 and 1.
What is the range?
0 and
Range is total. Range of Sn. What are the distinct values it is taking? All values, all are distinct only. But what is all the members here? They are positive and less than or equal to 1. We have done such questions also earlier. How to find upper bound, lower bound, we have done many questions. So all of them are positive. Generally, students, what they think and so on means not bounded, they think. But all of them are positive and upper bound is 1 because 1, 1 by 2, 1 by 3 decreasing. So whenever it is decreasing, I told you earlier the technique of finding lower bound and upper bound. Whenever it is decreasing, upper bound will be this, and the limit of the nth term will give you lower bound. Lower bound need not be in the set. Upper bound need not be in the set. 0 is not there in this, but it is the upper bound. It is the lower bound. Therefore, it is bounded. Sequence Sn bounded. Not only that, what is the limit of the sequences?
0, ma'am.
0. Unique. Finite and unique. Hence convergent. Therefore, the sequence Sn is convergent. Hence Cauchy. So we could generate a sequence which is bounded and Cauchy, which is not bounded, not Cauchy, which is bounded Cauchy. Both we have to know. Hence Cauchy sequence. Therefore, sequence Sn is bounded and Cauchy. There are bounded sequences which are Cauchy. There are bounded sequences which are not Cauchy. So is bounded but not Cauchy. So there are bounded sequences which are Cauchy. There are bounded sequences which are not Cauchy. If it is Cauchy, automatically bounded. But because it is bounded, we cannot say it is Cauchy. Okay. I hope it is very, very clear now. Any doubts up to this? You have participated excellently, because generally students think this sequence and series means very dull topic. It is this and permutation combination probability particularly. These are the topics because of teachers, students, and group theory, ring theory, all theories. Teacher effect is more. So you think it is very boring, but if you know the concept, if you enter into the concept, you enjoy it like any other topic. Now you feel problems are boring now, like ODE, PDE. Theory is very good. So this is maturity. Okay. So any doubts in this now? With this, we'll close this Cauchy sequence. And any other thing I have missed, Sarita? Can I go to series now?
Yes, ma'am.
Because I think almost 15 days gap, so even I forgot. Yeah. So monotonic sequence, I think we completed. Like this, many questions we have done. Any doubts, ma, from anybody else, or shall I go to a series now? But anyway, we should thank Sarita, because of this, you got some grip on sequences now. Without
Yes,
watching videos now,
Yes.
you came to know what is sequence now. Now series you will understand very easily. Okay, now I'm moving to series now. So let us enter into series now. What is the difference between sequence and series? Again, interview question.